Suppose a substance, we'll call it capital X, undergoes exponential radioactive decay. So that means that it obeys the law A of t equals A naught, that's our initial amount, e to the k, k is the decay rate, and t is the time that elapsed. Note that since we're decaying, that k will be negative. So the first thing we need to do is to find the decay rate. Let's use the information that we know. After 30 seconds, 10 grams decays to 8.3 grams. So let's plug in. Our A of t will be 8.3 grams. Our initial amount is 10. We don't know what k is, but t is 30. Let's solve this. First isolate our exponent, that way we can take a logarithm of both sides. Okay, let's natural log both sides, that'll get the k down from the exponent. Divide both sides by 30. Let's get a decimal representation of that. K equals negative 0.00621. We can go back to our equation up here. We have A of t equals 10 e to the negative 0.00621 t. To find out how much remains after 40 seconds, we need to plug in 40 for t. We'll need the calculator. We get 7.8, and the units on that are grams. When will there be 0.1 grams left? We're trying to find t when A of t is 0.1. To get t down, we'll be taking a logarithm, but first let's isolate our exponent. So divide both sides by 10. Take the natural log of both sides. So natural log of 0.01 equals negative 0.00621 t, and solve for t. And you get 741.6 seconds. Now we need to know the half-life. We could put in half of 10, which is 5, in for A of t, and then solve for t. Another way to do it is just to go back to our original one with the same k that we found, and put in 1 for A naught, so 1 gram. Then our A of t would be 1/2, and that saves a step. 1 times anything is that anything, so we don't need that. Let's take the natural log of both sides. So natural log of 1/2 equals negative 0.00621 times t. Solve for t. We get t equals 111.6 seconds.